The third form of our first order differential equation is called exact equation. How do we know that? Whether the equation that we look at is an exact equation. It said that you can prove it this way. When you have first order differential equation, you've got to arrange that equation into this form: m times dx plus n times dy equal to 0. And this equation will be exact equation when you do differential of m to y and differential of n to x. When you do m with y, you take a look at x as a constant. You do n with x, you take y as a constant. If these two are equal, that means this differential equation is an exact equation. That is the definition. Okay, so let's take a look at the example. It's just short and simple like that. Okay, set that identify whether this equation is an exact equation. This equation said that y squared dx plus 2xy dy is equal to 0. So if you take a, you've got to arrange this equation in this side: mxy dx plus nxy dy equal to 0, which is this equation in that form already. Right? It's in that form already. So our m is equal to y squared, and n is equal to 2xy. So in order to define whether this equation is an exact, we got to do differential of m to y. The reason why I take the curve because now it's a function of x and y. Okay. So if you do differential of m to y, what would you get? Hmm? 2y. And then you do differential of n to x. What would you get? When you do with x, you get y as a constant. You take y as a constant. 2y equals. So that means this equation is an exact equation. You can use the exact equation technique to find the solution. But if you look at this equation, you don't need to use exact equation, right? Is it a separable equation? Is it a separable equation? Is it a separable equation? Yes, it is. Is it a homogeneous equation? Yes, it is. So with this equation, you can use these three techniques to find the answer. So it is up to you. Like, I don't think you're going to pick the homogeneous because homogeneous is not easy. And then you have separable and exact, both of them are easy. So you can pick either one and the solution will be the same.